So on these panels, right? We left off yesterday where we actually triangulated just one set of 3 points, and those 3 points were here, and the surface was this. However, if I'm going to create a rotator that's based on the attractor point, there are two things that need to happen. Obviously, this point right here needs to be rotated before it gets to this position for the surface 4 point. But then we also have to create the relationship for the rotation. So the way I'm going to do this is you kind of just have to pick a point to test, and it doesn't really matter specifically which point, but well, it can, but in this case I'm just going to pick probably the point itself, the actual corner point here, and then I'm going to do the rotation. So I know that that needs to happen sort of in this gap right here, so I'm going to create some space for me to work. All right, so let's start with setting up the rotation. Actually, I think that's going to be the first thing I want to do with this. If I look at my options for rotation, under Transform Euclidean, I have a rotate an object in a plane. This is rotate from one position to another, rotate 3D, which does it around an axis vector, and then there's rotate an object around an axis. This is a line-based axis. So basically, if we wanted to go into the previous part of the definition, we could use one of these edges as our axis of rotation. And so that's what I'm going to do here. So I'll go and, or you could craft a new one. It might actually be easier to craft a new one like between these two rather than trying to list item. So I'll just do it that way. This is going to be quicker. So I'll just do a secondary line here and then plug that in as my axis. So you know the geometry that we're going to be rotating is the actual point itself, so that's going to be this. And it defaults to a 90-degree rotation. But since this is sort of a sun shading application, and if the positive direction is up, going that way, then I want to make this a negative relationship, and I want my maximum to be, or my maximum height to be at a rotational value of 0. And then I want my maximum or my minimum height or my maximum closed position to be at a little less than 90 degrees because these might have some overlap. So I'm going to do something like 80 degrees, negative 80 degrees. So I'll use, for now, just for right now, before I actually do the attractor point, I'm going to use a slider, and I'm going to say from negative 80 to 0. And that's going to be under, and I'm going to have to plug that in under math, trig, and radians. So that converts my degree desired input to a radius output. And so negative 80 is kind of just hovering a little bit over the panel there, and so I can rotate it this way. So now what that does is it creates an opportunity for me to simply replace this connection. I'll kind of put it back here with these other sliders, and then that geometry gets plugged into the surface 4 point instead, which is more accurate than, say, like a move command, because technically you can move it up and down, but this one is going to be physically accurate to what would actually happen in the real world. So that's the open position. This is the closed position. Are there questions on that so far? No? Okay. So then I'm going to run right into the closest point part of this construction. And we already have part of the definition that we need for it right here. I guess theoretically I could copy that part of the definition down, wherever that was. And it was right here. But I used a normal. Oh, because that one was an extrude function. I'll just copy these two. Actually, yeah, let me just copy everything up to the remap. That's because essentially what I need to do is I need to take those numerical values and I need to remap them to what my rotational values are going to be. So now my numbers 1 to 5 are going to be something different. But let's pull this down here. And this is my point to test. And my cloud of points is going to be, it could be these original positions. Yeah, actually it will be these original position points. So I'll plug this in here. And I'll leave it down here. And so let me just follow along on this thing with a panel real fast. So what that gives me on this output is a list of numbers, basically, that are distances. And so if that list gets flattened, actually let me just go back this way. If that list gets flattened on the input, that's going to be the proper structure we need. Remember yesterday we did that whole flattening exercise with this? That allows us to actually remap those numbers into something that right now it's set to be between 1 and 5. But if I want it to go from a closed position to an open position, then I want this to be from a minimum position of -80 and a maximum position of 0. So that means this is my minimum numbers, the ones that are closest to the point. Actually, it should probably be the other way around. It should probably be the other way around. Well, I'll show you what it does, and then we'll go back to it. So that's going to take the place of this radian input. That's just going to be done using this instead. So if you plug that in, you just need to make sure that it's grafted by the same number of inputs. So this has 35 values. This has 35 values. So I should be able to graft it once and plug it in. And get rid of these. And let me turn off some of the extra stuff. Oh, look at that. The order must be off. Huh. -80. They're not in order. Graft. 35 values, 35 values. Just a moment. Okay, so I think I figured out what was going on. And just as a heads up, I switched this from 0, or from -80 to 0 to be from 0 to -80. I'm just guessing that's the order I'm going to want it, but the problem here that I'm having is that I didn't switch it to radians. That's why. So I'll do that real fast. I'm just going to have to go to Math, Trig, Radians, plug this in, plug that in, and there you have it. It's a little bit smoother. So let me clean it up so you can see a little bit more. There you go. So the ones that are closest to the bottom are more open. The ones that are closest to that are more open, and the ones that are farthest away are more closed. And I think it would be reversed if I did that. Yeah, there we go. So the ones that are now closest to my attractor point are closed, and the ones that are furthest away are open. So that's essentially the construct here. The way that I've set it up is that every single horizontal datum is going to be calculated as its own line item, basically. So everyone, how do I describe it? Every single one of the triangles on this panel are going to have the same rotation. Well, not exactly the same rotation, but it's going to be mapped proportionally separate from this whole set as a list, if that makes any sense. anyway, it won't really matter on the grand scheme of things. So what I think I quickly want to do, just to kind of wrap up the thought, is to show you the process of getting the second level of this done, and it should be right here. So this list item allowed us to select the particular panel upon which we built this entire follow-up of this definition. So if we take the list item over, copy and paste it. Actually, let me do it this way. I'm going to group it and then copy and paste it. Now theoretically I should be able to just change this to the next one down and it should work. And it does, however, this one for some reason is not quite the same there. Because this is still, I see. So it's still rotating that original point, but it's rotating it around a different edge. So rather than, what did I do with this one? This was a divide for, oh, that line. Okay. Oh, right. All right. So then this one will just have to be the next index item. There you go. That's more accurate. Okay, I think that just about sums up the panel B structure. Do any of you have any questions on that? Hearing none, I will leave you guys to your devices on this. You can see here the difference between the two and how they relate going up the whole thing. I'll leave you guys to complete it. Remember that it does need to have an armature as well, so you can just basically take this edge and beef it up and make it a three-dimensional pipe or something like that if you wanted to do it that way. Okay.